Hi there, welcome to the Food Chase training. Today we start our module number 9 of the Smart and Sustainable Food Production System. And the main subject of this module number 9 will be climate change impacts on agriculture supply and efficiency. This topic, this theme is so updated, so important for us that I'll be making some emphasis on some of those slides that I'm about to share with you. And I really hope you enjoy this presentation and take the time to read the papers that I have included on this presentation and the articles and papers that I have included on the bulky presentation, which is the document, extensive document I have put together for you, so you can access and learn a lot on that. Let's start our class by learning the outcomes. At the end of this sub-module, students will be able to describe how climate change and global warming affect the availability and quality of agricultural raw materials, explain changes in weather patterns and their implication for agricultural production systems, very important, this for our sector, analyze the impacts of climate variability on production efficiency and operational stability, identify key risks and vulnerability in agri-food systems linked to climate change, as well as relate climate impacts to European Union Farm to Fork, Green Deal and climate adaptations objectives. Let's start our class, our module. Climate change and global warming represent structural challenges to modern food systems. You see, it's not a challenge, a single and separate challenge. It's a structural challenge. And we use this expression as a structural challenge because it actually impacts negatively different parts of the entire food system, not just the harvest, not just the planting, but the entire thing. That's why we call it structural challenge, okay? Rising temperatures, altered precipitation regimens, and increasing frequency of extreme weather events are reshaping the reliability of raw material supply and the efficiency of agricultural production. Very, very sensitive theme here. Within the European Union, climate impacts are already visible through more frequent droughts, heat stress events, irregular rainfall, floods, and storms, directly affecting crops, livestock, and supply chain stability. Next slide. Climate change is a systemic pressure. Remember, not just a figure problem, but a systemic pressure, a pressure that implies challenges on the entire system level. Climate impacts operate as a cascading system pressures affecting field level productivity and quality. Imagine you're expecting 400 millimeters of rain for your wheat to sprout, and you're not having 400, you're having 800, or maybe you're having 100. This is why this changing climate affects field level productivity and quality, okay? Operational efficiency and timing. Imagine that you must get into the machinery for harvesting now, but the weather is too wet. You cannot get into the field to harvest your hip if it's too wet, okay? That's why it acts on operational efficiency and timing. One very simple example. Processing, storage, and logistics reliability, very important. And the Farm to Fork strategy recognizes climate change as both a driver of vulnerability and a core rationale for accelerating the transition towards sustainable and resilient food system. Very interesting, this approach from the Farm to Fork strategy, because it sees the climate change not just as a problem, as a challenge, but see as a rationale, a core rationale that can speed up the changing process toward the more sustainable and reliable systems. Because people, they struggling now to produce, and they actually live in it on their daily lives. That's why it's so pertinent, and we must use such a pertinence to push the change, okay? And here, it's a figure that I have extracted from one of those papers I have mentioned at the beginning of our module that talks about climate change impacts in food systems, some environmental outcomes of climate change, such as increased drought, like I said before, rising sea levels, increased flooding, increased salinization of some areas, erratic rainfalls, very challenging, increased storm intensity, increased carbon dioxide emissions, temperature, and increased desertification. That leads to increased disease severity, lower yields in many cases, lower nutritive quality. If you have to change the timing of sowing, the time of harvesting, probably the bricks on the fruit, or maybe the nutritional condition on the fruit won't be the same as a fruit that has grown and developed itself on a balanced environment. That's why the lower circle here on the blue color, its number is named lower nutritive quality. Okay. Next slide talks about the topic of impact on raw material supply. And the objective of this chapter that you can access on the written material is to understand how climate change affects the quality, reliability, quantity, reliability, and quality of agricultural raw products. And the key dimensions we're talking about here is the yield variability, supply stability, and quality and functional characteristics of raw material. Okay? Yield variability and supply stability. Climate change increases yield variability through heat waves during flowering and grain filling. We don't want those heat waves, but happens to occur and directly impacts on our yield variability because you have a high temperature on the phase that you don't need a high temperature. More frequent droughts on the phase that the plant needs more water, depending on the crop, flooding, storms, and late frosts. These stresses disrupt key physiological stages of crop development, leading to unstable yields and increased risk of crop failure, especially in rain-fed and climate-sensitive systems. You see here, these are the colors of impacts on the orange by 2050, on the green by 2030 of the countries, how they will be affected negatively, or some rarely ones, but positively, okay? The majority of those countries that are listed here will be suffering losses on the productivity, on yield, specifically, there's a number related to yield, that's a percentage. Most of them by 2050, if they don't change the current scenario, they will be struggling a lot to produce. Some can reach up to 37% of losses, such as Thailand, such as Mexico and India. Mexico not as much, but India, Canada, and Bangladesh, okay? Heat and water stress effects. Heat stress accelerates senescence and reduce reproductive success. Accelerate senescence is the dying back of a plant. A plant is supposed to be for 40 days in the green stage, but it's now 30 days because the senescence is just playing harder. And reduce reproductive success, okay? Instead of having sprouting of 98%, have a sprouting of 89%. It's a very different figure, okay? Drought limits nutrient uptake in canopy development. Combined heat drought stress produce non-linear yield losses. Why non-linear? Because it's hard to predict. You know, it's not a curve that has a rhythm, it's a non-linear. And it's very hard to predict. The loss will occur, but how strong? We have not known. Even short episodes of extreme stress can cause disproportionate yield reductions, undermining year-to-year production stability. Okay, these are the figures A, B, and C, showing that how the heat and the water stress will be affecting the agriculture produced on those countries. As dark as the red is, strong the impact will be. And you see how it be back in the days and how it will be in the future, okay? And this is very important for you to have a read on this article. It's an article that has been published on the Nature Communications, I think, which is a very top-level paper, meaning that the information that has been gathered and the information that's shared, it's a very high level, help you a lot to understand what's going on at the world level, okay? Because we may be somewhere around Europe thinking maybe this does not affect me, but it does. We share the same planet. That's why things happening over there will impact me here in this sense or other sense, but we are part of the same atmosphere, okay? And these are the impacts. You see how some of the countries will be suffering a lot, specifically in Southeast Asia here, around Bangladesh, India, and this Mongolia, southern part of China as well. So, and some areas of Latin America as well, okay? Quality and functional characteristics of a raw material. Let's start with the figure. This figure just shows the food economics in the food industry, known less of food, processed food, and how it enters the system and how we use functional characteristics and quality to take the right decision and to evaluate from quality to safety improvement using very high level and critical technologies such as chromatography, NMR, MAS, and etc. Okay? Climate change affects raw material quality by altering protein, starch, and oil composition. Okay, and how do we identify the changes on this? By using those machinery on the right-hand side here. That's why I've put this on purpose. Okay, grain size, fruit uniformity, and tissue structure, they affect negatively on that. Moisture content is storability, meaning that if I have a fruit that can stay on a shelf life of 14 days, I may be able to store it for 10 days because I don't have uniformity on the moisture content that will be, example, will decrease the storability. Okay, that affects directly on the food industry. These changes directly affect processing efficiency, storage and stability, food safety and product consistency, even when total yields remain stable. Even though you are harvesting the same 2 tons of fruit per hectare, maybe 2 tons is a very low, but just give you an example. Those same 2 tons, they don't have the same sensorial characteristics, they don't have the same uniformity, they don't have the same bricks, or maybe the same quality, same oil content, and that will surely impact negatively on the food industry and at the consumer, at the end consumer as well, okay? The next slide is about food safety and post-harvest risks. This is a paper regarding the Sustainable Development Goal number 12 and sub-items 3.1a, okay? And it just explains the cycles from the pre-harvest to the household consumption and here to disposal, and how the losses, they occur on different phases from pre-harvest, harvest handling, storage, transportation, processing and packaging, wholesale and retail, and household consumption. How we be losing this and what does affect such a waste generation on this, okay? In this specific case, we're talking about here on warmer temperatures and higher humidity that will increase mycotoxins contamination risks, which you can see on this figure as well. Pests and disease pressure, which is a problem on the field level and might be a problem on processing line as well. If you don't sanitize correctly, you have this problem on the middle of your producing line. And post-harvest spoilage, okay? Climate-driven quality degradation increases rejection rates, waste generation and compliance challenges under European Union food safety regulations. Remember, if you collect the same amount of fruit you have collected on a good year, but you are not complying with the European Union food safety regulations, at the end of the day, you lose the majority or maybe some important part of your produce. That's why our action as technicians from the food industry, normally they begin on the field and they result on the consumer, the last end processing part on the consumer, the final consumer. That's why I have advised you on the module number 5 or 6. If you're working on the food industry in Europe and you have the chance to visit your supplier, do it. Because by doing so, you help building trust between both parts, the industry and the producer, and helps you understanding the production itself. What would be the struggles of this producer? How can I actually help this guy to produce better, which will help him having a better product? It will impact directly on my thing, because I'll be receiving a better fruit. That's why I, myself, as a technician, I've been working for many years, nearly 2 decades on the ground, and I always try to visit farmers because this makes a total difference. When you are in contact with them, you can actually feel the pain they feel, and you can actually understanding why a given fruit or a given vegetable is actually not attending the standard you're looking. Because sometimes it's not a technique, sometimes something easy that you can actually help and having a better product, himself and yourself, okay? Changes in weather patterns, very important subtopic. The objective of this subtopic is to analyze how altered weather patterns increase agricultural risks, and the key drivers we do understand here are temperature extremes and heat stress, altered precipitation regimens, and increase the frequency of extreme events. Temperature extremes and heat stress, the first one. Rising temperatures and heat waves, they shorten critical growth stages, very, very impactful with. Reduced biomass accumulation. Remember, the biomass accumulation has total relation with the water retention and moisture retention. and it does impair pollination and fertility. Very sensible, very important, this bullet point here. Impair pollination, meaning it does not mean that it will avoid, because if it's no pollination, no production, but it will negatively impact pollination by impairing it, which will result in emergence, fertility, and etc. In livestock system, heat stress reduces feed intake, the animals tend to eat less, productivity as a consequence of eating less, and reproductive performance, which is related, reproductive performance, to nutritional status of an animal, while increasing cooling energy demands and disease risk, okay? This figure here, the world map on the left-hand side, the figure A, shows the moderate to severe food insecurity in percentage of the population in the world. You see that? As long as you get to the yellow side, as hotter as the color is, from yellow, more food insecure the country is. You can see that the sub-Saharan Africa is always a hot spot. Some areas here in Southeast Asia, South America, a part of Venezuela is not as strong, but still have some food insecure places. And these tend to be even more by temperature extremes and heat stress, even more affected by. So we will be noticing more food insecurity severity in those places, okay? And this is the average food insecurity on percentile year UTCI. This has been depicted as well from a Nature publication, which is a very high level publication. You can explore this graphic, which is very interesting for you to understand how the food insecurity is affected by UTCI, by the perfect percentile of a year, how it is different from country to country, from how it is impacted by temperature extremes and heat stress. Okay, it's a very important paper for you to read. Altered precipitation regimens, one of sub-items I have named before. Climate change reshapes rainfall patterns by increasing intense rainfall events causing runoff and erosion in areas that maybe didn't happen there. I tell you a story. A couple of years ago, I was working in Peru with organic food supply and organic fertilizer supply. And we had a problem with El Nino and with some changing in patterns of rainfall. In some areas of the Peruvian desert was hit by a strong rainfall. So the houses, the structure, all the infrastructure was not prepared for that. So there was a very, very strong problem for that. The food industry suffered a lot, okay? In other cases, longer dry spells and drought frequency, flooding and waterlogging risks, and these patterns complicate planting schedules. You have to adapt the planting schedules, irrigation planning, and soil management, increasing operational uncertainty and production risk and costs, okay? This figure here on the right-hand side of my screen just shows some of the changing precipitation patterns. On the right-hand side as a meaning of drought, and the left-hand side as a meaning of increased precipitation. And it is actually divided in a few. This paper divides the impacts of a change in precipitation into survival, performance, pest population, pest life cycle, migration patterns, distribution, predation, and parasitism. This shows some problems on the crops from both drought and increased precipitation. You see that when you have unbalanced weather, we have different behavior of pests and diseases and performance and pest population. This paper talks about it. It's very important for you to read if you want to understand how the climatic instability influences predation, distribution, migration patterns, pest cycle, and etc. Okay? Extreme weather events and operation disruption. Extreme events act as acute shocks that cause sudden crop damage and failure. We know that. Accelerate soil erosion, nutrient loss, damage infrastructure and storage facilities, disrupt harvest and logistics. Such events generate unplanned downtime and high recovery costs. You have to restart again your system many times, in some times. Undermining long-term productivity and investment capacity. This is a very sensible thing to talk about, but it's very important for you to understand how those extreme weather events disrupt operational activities. Extreme weather system and events. Here is a a figure just describing general extreme geophysical events such as earthquake and how those different weather systems, extreme ones, they actually affect the food system. This paper talks about hazardous impacts and divided by temperature, precipitation, and wind, how they impact the production, how they impact our daily activities, specifically those working on the food industry, okay? Impacts on production efficiency and supply chains. Climate stress reduces efficiency by lowering water, nutrient, energy use efficiency. So it's inefficiency under energy, nutrient, water use. It's a very, very broad problem. Increasing input requirements per unit of output. Example, I needed for each 10 kilos of fruit, I used to produce 7.8 kilos of final product. Now I need 12 kilos of fruit to the same 7.8 kilos. That's why we say increasing input requirements for per unit of output. Okay? Causing operational delays and downtime. At the supply chain level, climate variability disrupts procurement because it's hard for you to find the raw material you need. Processing schedule, contracts and market stability. Increasing price volatility and food security risks. This is represented by this figure on my right-hand side that it's connected to the feedback mechanism of agricultural activities on climate change. How greenhouse gas, supply chain, and deforestation and use change, they are interconnected. How they influence each other on a different manners. The paper talks about it, and it's very updated and valid nowadays, okay? This was the module number 9 about the climate change impacts on the food production and food chain. We needed, like I said yesterday during the module number 6, we needed at least 20 hours to explore this module. But I'm sure that by reading the written material I have put together, have shared with you, by watching the videos and reading the papers, you'll be getting a lot more acquainted with the subject than you was previously. I hope you have enjoyed this class, and don't hesitate and drop us a message. We'll be more than happy to share with you some insights, ideas. And do not forget to make the exercise because those exercises will help you fixing the knowledge. Have a great time, and thank you once more for your time.